right, I think we're ready to get started. Eric, what do you think?
Awesome. Yeah, happy to get started. So first off, just want to thank everybody for joining us on this Tuesday morning. We're really excited to talk about the urgency of enhanced coding curriculum to meet the new ISTE standards and to show you a little bit of what Learning.com looks like from that perspective, get some questions answered for you, and then reach out at the conclusion of this webinar and continue those conversations and learn a little bit more about how your districts might address some of those needs. So, Dan, do you want to hop to the next slide so we can do some introductions and then we'll go from there?
Yep.
So let me introduce myself first. My name is Eric Detman. I'm the Regional Partnership Manager for Learning.com. We've got Fran Amar, who's on the call. She's the Customer Success Manager for Learning.com. We both specialize in the Northeast region. And then Diane Connick, who's the Senior Implementation Specialist for Learning.com. So we've all been here for a number of years. We would consider ourselves experts when it comes to not only our curriculum, but the needs of your districts within the Northeast. So happy to be here, happy to help. A couple of things to note. If there are questions, on the right side of your screen, you'll see a drop-down box that either has a section called chat or questions. Feel free to put your questions or your thoughts into those sections. And Fran and myself will make sure that we get or relay those over to Diane, or if we have the ability to answer them directly in the chat box, we'll do that. So with that said, Diane, let's jump into the presentation, let you do your thing.
Thank you. Let's go ahead and let's talk about the agenda real quick. We're going to talk about what and why about computational thinking and coding, and how those two topics support the ISTE standards. And then we're going to talk about specifically about the K-5 classroom with computational thinking and coding, some implementation ideas and best practices. And then I have time for some demonstration of our coding content, and then Q&A. And then like Eric said, if you have a question as we go through, please put it in the chat, but definitely there'll be some time at the end to do a Q&A as well. All right, let's start with this quote. Save some bandwidth here. All right, so Steve Jobs said that everyone in this country should learn how to program, because basically it teaches you how to think. So I'd love to start with that quote, kind of sets the stage. So my first question to you is for you to think about, and if you want to put it in the chat, you can, but what is computational thinking? So the definition of computational thinking, it's a set of skills and processes that guide problem solving. So computational thinking is problem solving. So the question is, does that mean that computational thinking is coding? And not necessarily, right? And for those on the call that know this really well, computational thinking is not coding, but computational thinking is the thinking that builds and leads up to coding. Computational thinking is more of the problem-solving process that leads to code, but coding is more the process of programming different types of digital tools and algorithms. So there is a distinction, but they are connected. So when I talk to districts about coding, to me, the two go hand in hand. I like to talk about them together. Computational thinking and coding as you know, kind of little two peas in a pod, all right? So why coding? The 4 C's of coding, and you can see here, creativity, collaboration, confidence, and then the computational thinking. So, and we're seeing the importance of coding and we're seeing it in more standards as well, national standards and state standards as well. We're seeing that coding is becoming a basic literacy in this new, digital age that we're in. And that it's important for students to understand and be able to work with this technology around them. So here's just a graphic of the ISTE standards or topics, right? You're probably familiar with these. So if you look at these, and just to review, you know, the ISTE standards are kind of like a framework for innovation and excellence in not just learning, but also teaching and leading. You know, there's standards for students, teachers, and administrators. So when you look at these standard topics, right, for students, where do you think coding fits in this, you know, in this graphic, in these topics? And there's can be more than one answer. I'll let you think about that. Yep. All right, so we're going to start with, probably the most obvious is the computational thinker as the standard, or as the topic that fits most naturally, and there's others as well, and we'll talk about those. But I want to really kind of dig into the ISTE standards and just kind of review some standards that that I feel like really make that connection to coding and computational thinking. All right. So kind of the description of computational thinker is students develop and employ these strategies for understanding, solving problems, leveraging that technology, and develop and test those solutions. So this standard really, the student I think it's 4 different student expectations under computational thinking really fit well, right? So we start off with students formulating that problem definitions, using technology, data analysis, abstract models, algorithmic thinking, and exploring and finding the solutions, right? That sounds like coding, right? And then if you take it a step further, 5.B, where students actually are collecting the data, identifying the data sets, using the digital tools, analyzing them, and then representing them all around and you're going to see the word problem solving often, right? And decision making, right? 5C is where they break apart those pieces, kind of pull out those key information and develop these models to understand complex systems. Once again, that problem solving, that's a big part of it. And then the last one, 5.D, is where students really understand how automation works. And they use that algorithmic thinking to develop a sequence of steps to create and test. That, to me, right, segue right into the coding. Being able to, you know, write those algorithms. So basically, computational thinking includes 4 concepts, just to review, kind of a decomposition, pattern recognition, abstraction, and algorithmic thinking. Another one that comes to mind is innovative designer, right? If you're thinking about coding. So innovative designers, where students use a variety of technologies, thinking about that design process, and they're solving problems, and they're creating new solutions to solve those problems. And they're using their imagination and their creativity, right? So that goes back to our 4 C's of coding. 4.A is, you know, they know and use a deliberate design process for coming up with ideas, testing their theories, creating artifacts, or just solving real world problems. 4.D, students, and I love this one, students show a tolerance for ambiguity. So when things are hard, right? And sometimes this happens when you're learning how to code. Things are hard, but you persevere, and you're comfortable working on those open-ended problems. I love that. I love that standard. The third one that I kind of picked out that I wanted to talk about was the empowered learner. So this, the description overall of this standard, ISTE standard, is, that students can leverage this technology and really take an active role in choosing, their learning goals and informed by the learning sciences. So specifically, 1B, they're building these networks and really customizing their learning environments. And then 1.C is where they use this technology to seek feedback. And they take that feedback and they're trying to make improvements to their practice in a variety of ways. So that's, if you haven't, I guess, looked at the ISTE standards in detail, those are some that I kind of cherry picked out just to kind of bring to the forefront of coding. And then I'm bringing this slide back just to talk about why coding is important, and really just kind of review the 4 C's of coding. And hopefully you heard creativity, collaboration, confidence, and computational thinking throughout those specifics of the ISTE standards. Okay. So the question I have is, when should computational thinking and coding be taught? In many districts, I see that students really don't get their first introduction to computer science and coding until middle school or high school, right? And I believe, and I've read lots of articles, ISTE has one published recently that talks about the importance of getting that computer science program into your pre-K through 5 classroom, and the benefits of that. So the first one is, and if you know elementary students, right, computer science is fun. So they're highly engaged, right? Their little minds are like little sponges, right? The second one, there's a lot of things in number 2, but it really introduces computer science to all students. It's not an elective, right? Everyone's introduced to it. So there's no gender gap. There's no stereotypes. And it increases that momentum for computer science in middle school. So when it comes to time for computer science in middle school, everyone has been introduced to it. It's not something that students just choose to get involved in. Number 3 and number 1 actually are related. Parental involvement, because students are excited and engaged, they're going to go home and talk about it, right? So that so that's number 3. And then 4, we just talked about this, right? The ISTE standards and computational thinking competencies that start in kindergarten, right? So the standards are there, and having a coding program in your district starting in pre-K helps to address those ISTE standards early on. Okay, best practices of implementation, and really these suggestions actually come from ISTE, and it's not just about coding specifically, and really these are just good implementation ideas. So now we're going to kind of switch into kind of the ISTE standards for teachers. So the first one is you want to encourage your teachers. So let's kind of switch gears here to thinking like a teacher. we want to encourage teachers to continue to learn. You know, once they're introduced to computational thinking and coding, we want them to keep learning, right? Things that are, you know, they're going to continue to want to do that. The more they learn, the more they're going to improve, you know, that practice. And I'm going to assume also the more they learn, they're going to see that computational thinking and coding is not just for a computer science classroom, but there's tons of cross-curricular connections that they can make. So that's the first one. Continue to learn, continue to lead. And when I say continue to lead, I mean not just at a campus level, but also, you know, a teacher is a leader in their classroom. So, and students and other educators are watching. And so, you know, teachers have this opportunity to promote computational thinking and coding to their peers and to their students. And the benefit of this, of being a good computational thinking and coding leader, is that, and especially if you have a program in your elementary, is you're really going to, you know, kind of counter those stereotypes so that all students feel that computer science is open to them, right? The next one is to continue to collaborate. The more, and these are kind of build on each other, right? The more teachers learn and lead, naturally the next step, or what's intertwined in all of this, is collaboration. They're going to, you know, incorporate these diverse perspectives, all these skills that everyone has, and kind of put them together. All right, and then continue to creatively design. So computational skills can empower students to create great artifacts that allow for personal expression. And educators kind of lead that, and they design that, and they give students those opportunities. And then continue to integrate as teachers do, you know, continue to learn, lead, collaborate, all of those things. They are going to find out that computational thinking and coding is not just for the computer science classroom, it's everywhere, right? Seeing those algorithms and algorithmic thinking, breaking things apart, solving problems, all of it's everywhere, right? So as naturally this is going to happen. They're going to find ways and everywhere, right, to continue to integrate computational thinking and coding into, you know, into their classroom. You know, I even say like in the lunchroom, right? So I say coding is everywhere. It's the English language arts classroom, the math, the science, social studies, even in the arts. Okay. So that's just an overview of how teachers can get involved. So when we're talking about a campus implementation or a district implementation, and these are recommendations from ISTE as well, set your expectations and make them known and repeat them. Make sure your expectations are included in, you know, system-wide planning, school improvement, technology plans, and then make sure that you provide teachers with the training that they need, the professional development that they need. Or if you have a teacher who's really, you know, wanting to really focus on that as their own professional growth goals, encourage that. Map the curriculum, help teachers out by helping them plan, by putting it in their curriculum where it makes sense. Maybe gather up a cadre of teachers to help get feedback to do that properly and to do that where it makes sense. Think about the technology when you're doing this and you're planning the curriculum and you're mapping it out, and you're really designing your lessons or curating your lessons. Make sure that you're being purposeful about the technology use. and not just using technology for the sake of using technology. And then, of course, think about your learning management system or your web system, or whatever it is your district is using. You want to make sure that you involve your IT department. And then, and I know I keep saying this, computer science and coding is not just for that classroom. Think about ways throughout the day that a student can have access to computational thinking and coding. All right, take a little pause. Any questions or any topics that we need to discuss while we kind of transition to the next item? Okay. All right, so Learning.com EasyCode, it is our curriculum that pre-K through 12 teaches students to solve problems using coding, right? So it starts with block-based coding, and I'm going to show you a sample of each of these kinds of items. Block-based coding, CoffeeScript, there's even an intro to game design, of course, computational thinking, and we'll actually start with that. Python, and then we're adding a cybersecurity course as well. So our curriculum builds on each other for all the way from elementary, middle school to high school. You'll see that it aligns to state and national standards like ISTE and CSTA. It's completely web-based, it's engaging, it's interactive, it's game-based. And then you'll also see some real-world projects, kind of as a culminating activity. Management tools, of course, talk about usage data and everything like that. But basically, it really immerses students in this block-based, text-based programming, and then including Python in middle school. Right. I'm not going to show slides for these things. We're going to just talk about them as I show them to you in the wild. So let me switch tabs real quick and make sure I'm still logged in. So what you're seeing now is our student interface, so a gamified map. What I'm going to show you, everything has different grade levels. We're going to start off really simple. So we have lessons that start in pre-K and kindergarten that teach computational thinking. For pre-K 2, the two topics are patterns and directions, which is very age appropriate. So this lesson is, and I'm about to click on it and give you a quick little preview, but this lesson does two things. It teaches students about computational thinking using patterns, and then there's a stop and check for understanding throughout, so students can actually practice what they've just, what they've just learned in the interactive lesson. So let's just take a quick little peek. And I've actually already started this lesson, so they've been introduced to patterns.
Look at this pattern of different colors. Which one of these other patterns?
What's nice about this lesson also is the topic is this bakery. And of course, kids love food, right? So they're asked to choose the pattern that has the same rule as this top pattern here. So they're really trying to, make that transition from shape, different shapes. So I'm just going to pick one and let's see. Okay, I got it wrong. So I need to choose another one. So just shows you what happens when students get it wrong, and then they immediate feedback, and then it moves on to the next concept. Students need subtitles turned on. I'm just going to show that real quick. Okay, so looking at the pattern, I can tell that it's going to be chocolate frosting next. And then the vanilla. I'm going to stop here and exit. So that gives you just a taste of our computational thinking lessons. There are lessons, this obviously was a K1-2 lesson. There's different more advanced topics for 3-5, and then there's also middle school lessons as well that teach the computational thinking concept. So I tell districts, teachers, coordinators, you want to make sure that you teach those computational thinking skills before you kind of jump into coding. These lessons are designed to be done independently by students. They just log in and launch the lesson, and it's automatically scored and graded. But especially for younger students, or if it's a concept that a teacher feels like maybe too difficult, it can be done whole group. Put it up on an interactive whiteboard or whatever. So, all right. So next is what I want to show you is our pre-K through first grade coding activities. All right. So this is for our non-readers. So you're going to see, first let me turn off the sound. You're going to see there's no reading involved. I'm actually going to go back just a little bit. Oops. Let's do this one. No reading is involved. Just lots of symbols. So basically the concept is the students, and they're introduced to this at the very beginning, they move the monkey to get to the banana and the treasure chest, right? So they just use clicking in the least amount of steps, right? And they'll figure that out pretty quickly. They're also introduced to, so here we have directions, and they're also introduced to the run or play, icon. So let's see here. Let me run or play that. See how I did. There's a little celebration dance. And then I'm also earning stars at the same time. So students, this starts off very simple, just moving the monkey, one direction or another, and then slowly it introduces into all the different icons and so on. So this is for, like I said, pre-K, K, and 1. Just gives you a little sample of that. The next one I want to show you is for more for our like first, second graders. So we're introduced to a beaver. Lots of challenges. Once again, I'm going to turn off the sound. Lots of ways to move. So now we're introduced to more of a click and drag block-based coding. So we kind of transition from just directional icons to some block-based coding. So here, let's see, we want to move the beaver to the right and then drop. So let's just see what happens when I do that. Oh, and it gives me a little indication that I was close, right? I have option of hints. And then I can go back. So this is where that standard of persevering, right, comes into play, right? I call it trial and error testing and implementing. So this is how that looks for the beaver. Each challenge, so this is completely student directed. Of course, there are teacher lesson plans that coordinate with that, but students can just log in and start at the beginning, and there's just I call them little micro steps of learning and using these coding skills and directions and so on. So this is for first and second grade. So that gives you an idea of that. Like I said, we kind of have transitioned, so we have block-based coding, but then we also have the words on the blocks. So, you know, we're making that transition there. The next, here we go. Next item I want to show you is coding adventure. We still have, oops, hold on. Sorry about that. Here we go. Coding adventure. So same thing, we have a, oh no, I'm gonna turn off the sound. Okay, so we have a monkey and he's trying to get to the bananas. Okay, so they're, if you started in kindergarten, they're familiar with the concept of getting to the bananas. And actually, you'll see I'm on challenge 10. If y'all don't mind, I'm gonna kind of go back. I like to show this kind of earlier on. Okay, so this is more kind of transitions into more text-based coding. They do have this option of using these little tiles down here at the bottom if they need it, but from what I've seen, students very quickly become very comfortable with typing the text in. Okay, so it showed me how to use the ruler, so I'm going to use that tool that it showed me. All right, and I can come in here and use my keyboard. It's actually the first time I've used my keyboard to code. And then I click run. Okay, there's a celebration. And then it moves on to the next challenge. So once again, each challenge builds on the other. Gives you a little tip of what to watch. You can even, there's a little tutorial, right? If students wanted to, you know, really see that. All right, so, and actually this has a little bit of, you know, we have to correct some things here. So turn, not left, I want to turn right. I can either type that in, or if you've noticed, it's got little icons down here. I'm going to measure. It is 12. So let's run that and see how it looks. There we go. Okay. All right, so that is coding adventure. This coding adventure, I didn't say this up front, is for grades 3 through 5. Okay, and it keeps encouraging me to keep playing. The next item I want to show you is moves more into the Python. Now, coding adventure does have a Python component. But this is, okay, let's get started here. But this is more of your middle school Python, okay? And I like to start, when I show this, I like to start at the very, very beginning. So students, there we go, prompted with some instructions. So students just start at the top and read the directions. It also has embedded in some icons for them to, you know, to look at. If students need audio support, it does have a little audio support that reads it to them, kind of like with a screen reader. And then the toolkit over here on the left. So what I love about this is it does, so this is the very beginning. So at the very beginning, they're introduced to these icons of running, submitting, and going next, okay? So when I run this program, the box drops down, and I'm supposed to click on it, and it does a little spin, you know, so students are introduced to what they can do with this stage that they're introduced to. Okay, and then we're ready to go next to the next step. All right, and it tells them step by step what to do. Look in the toolkit, find the stage, click on it. Choose summer. It tells students everything to do. So if you kind of follow along the top, so there's a preview, and they're introduced to all these little different pieces that are going to build on each other, like a background image, changing the background. There's debugging throughout. They're introduced to sprites, changing the sprite, another debugging, and so on. And then there's 3 different exit tickets at the end. There's one that's like I'll just click on it and show you this one. It's a multiple choice questions, right? Check for understanding, as well as extension ideas where they're creating or modifying. And then actually this one is extended where they're modifying. There we go. And the last one is where they actually create. And they actually, in this case, they start with a blank stage, right? And they use all the tools that they've learned, their sprites, their movements, their backgrounds, and they create an e-card. They're given examples. There's little tips within the stage here that they can use. And then when they're ready, they submit, save and submit. Okay. So that and all that is just one lesson. Okay. And you can see here, there's multiple lessons. There's actually more than what's showing right here. This is just the intro right here. Okay. I probably should tell you how there's just, 25 challenges and, it's just, but we can talk about that in a minute if we want to, what's included. Also within, I didn't mention this before, but within the coding challengers, there's also opportunities for game design, and those kinds of app design. There's all kinds of things like that. More on the creativity side. Okay. All right. Now let's look at. I don't see any questions or anything, so I'm just going to keep going. Now, what I want to show you is kind of a sampling of our cybersecurity. All right. So I'm just going to click on it right here. All right. So cybersecurity. This is what this is just a sample lesson. We're not going to go through the whole thing, but it has 20 different lessons that introduces cybersecurity and Python programming kind of integrated together. Fun, it's engaging. It does a really good job of introducing students to cybersecurity and at the same time teaching those kind of foundational coding concepts using Python, which we already kind of talked about that. There's didactic lessons, and you'll see this in a minute, with coding as well. All right. The concepts are communication systems, hardware, network, software, internet, security, digital citizenship, and then all kind of different concepts of data types, variables. That's more the programming side. But let's just take a quick look. So actually what I'm going to do first, just to give you an overview, is kind of go across the top here. So there's an intro to cybersecurity. And there's 2 different parts to talking about systems. There's a check for understanding. There's more about systems thinking, cybersecurity systems. So everything, you can see the kind of scaffold progression, right? There's a case study, which is really cool. There's a vocabulary section. and then future of cybersecurity, and then coding in cybersecurity. So anyway, let's take a look at a few steps here. Guides them through. So here's the instruction part and the vocabulary part. Great graphics. It's interactive. Click on cyber. It tells you what that means. Security. And puts those things together. So it's guide students through through the instruction. Lots of different graphics to keep their attention. And then, of course, the submit and continue to have them move on. And I think I'm stuck. Right, while we're waiting on that, questions? Because I know we're kind of coming up to the end of our time. See anything in the chat?
I'm not seeing too many questions, Diane, just a lot of really thoughtful feedback and thoughts based on the progression of your presentation.
Okay. All right. Eric or Fran, is there anything you would like to add? I'm going to try to refresh this. I'm going to blame it on my computer.
I think the only thing that I would add, and thanks for walking us all through this, is at the conclusion of this presentation, what we'll do is we'll save this presentation and then we'll send it out to each of you. We'll reach out individually to start some conversations. We've already been having some really meaningful conversations in the questions and chat boxes. So thanks so much for being so engaging. But we'll be reaching out, having some additional conversations, setting up some meetings, learning a little bit more about how your districts are currently teaching some of these skills, and seeing if there might be any additional questions that have come up from the presentation. So, Fran, I'm not sure if you have anything else, but that's kind of the main piece from me.
Nothing else for me, actually. Thank you. I just want to, I know it's a crazy time of year, so I just want to thank you all for spending the morning with us and learning more about ISTE and coding.
Yeah, absolutely. We appreciate it.
Y'all have a great rest of your morning.
Thank you. Have a great day, everybody.
Yep. Bye.